Good afternoon. Welcome to your number one TV station news and update. I am Ken, taking you through this session. Stay tuned. We're back, and today we are going to talk the half reaction method, or also known as the ion electron method. Balancing redox equations. Half reaction method. A half reaction is the part of an overall reaction that represents separately either an oxidation or a reduction. Two half reactions, one oxidation and one reduction, are necessary to completely describe a redox reaction. Another method for balancing redox reaction uses half reactions. Recall that a half reaction is either the oxidation or reduction that occurs, treated separately. The half reaction method works better than the oxidation number method. When the substances in the reaction are in aqueous solution, the aqueous solution is typically either acidic or basic. So hydrogen ions or hydroxide ions are present. Step 1. Write the unbalanced ionic equation. Notice that the equation is far from balanced, as there are no oxygen atoms are on the right side. This will be resolved by the balancing method. Step 2. Write separate half reaction for the oxidation and the reduction processes. Determine the oxidation numbers first if necessary. Step 3. Balance the atoms in the half reaction after than hydrogen and oxygen. In the oxidation half reaction above, the iron atoms are already balanced. The reduction half reaction needs to be balanced with the chromium atoms. Step 4. Balance oxygen atoms by adding water molecules to the appropriate side of the equation for the reduction half reaction above. 7 H2O molecules will be added to the product side. Now the oxygen atoms need to be balanced in an acidic medium. Add hydrogen ions to balance. In this example, 14 H plus ions will be added to the reactant side. Step 5. Balance the charges by adding electrons to half reaction. For the oxidation half reaction, the electrons will needed to be added to the product side. For the reduction half reaction, the electrons will be added to the reactant side. By adding one electron to the product side of the oxidation half reaction, there is a 2 positive total charge in both sides. There is a total charge of 12 positive on the reactant side of the reduction half reaction, 14 negative 2. The product side has a total charge of positive 6 due to the 2 chromium ions. To balance the charge, 6 electrons need to be added to the reactant side. Now, equalize the electrons by multiplying everything in one or both equations by a coefficient. In this example, the oxidation half reaction will be multiplied by 6. Step 6. Add the two half reactions together. The electrons must cancel. Balance any remaining substances by inspection. If necessary, cancel out H2O or H positive that appear on both sides. Step 7. Check the balancing. In the above equation, there are 14H, 6 iron, 2 chromium, and 70 on both sides. The net charge of 24 positive on both sides, the equation is balanced. Example, zinc and copper galvanic cell. Consider the galvanic cell shown in the image to the right. It is constructed with a piece of zinc, submerged in a solution of zinc sulfate and a piece of copper. Submerged in a solution of copper sulfate, the overall reaction is at the zinc anode oxidation takes place. This is presented in the following oxidation half reaction. Note that the electrons are on the products. At the copper cathode, reduction takes place. Electrons are accepted. This is presented in the following reduction half reaction. Note that the electrons are on the reactant side. In general, the half reactions are first balanced by atoms separately. Electrons are included in the half reactions. These are then balanced so that the number of electrons lost is equal to the number of electrons gained. Finally, the two half reactions are added back together.